And we're back, but the problem is I just can't let go of Christmas. Look at these cool glasses I got from the dollar shop, or should I say the $1.25 shop now. Whoa. Woo. Okay, so we're just reviewing on that front page there. Okay, so this isn't too bad. All you're doing is switching the x and the y's. Inverse, switching the x and the y's. So if our graph is here at 0, 0, right? And we go over, like, I don't know, let's see, over to 2 it looks like. And then up 1, 2, 3, 4, 5, 6, about 7 or 8, we'll say 8 maybe. So that's going to be 2, 8. So that's going to be 2, 8, that's going to be 1, 1. And so we just want to go ahead and switch those now, right? We want to switch those. So this will be hard to see because we'll still have 1, 1. That is still 1, 1. But then this guy will switch and become over 8 up 2. So can you find a graph with 1, 1 over 8 up 2? So here's, let's see here. Maybe down here. Looks like down here. So that's over 1, so that's 1, 1. That's 1, 1. And then over 8 up 2. 1, 2, 3, 4, 5, 6, 7, 8 up 2. So there's our switch, right? There's our switch. So you'll notice it just kind of switches about like the inverse. So just kind of, we take that graph, like that. And then we like kind of rotate it, kind of thing, if it lets me rotate it. It's not gonna let me. Little. Okay, so you like rotate it like that, right? And you kind of like flip it up and down, kind of thing. Left and right, kind of thing. Boom, there you go. So you'll notice that it's symmetric or flipped about the y equals x line, okay? The y equals x line. Yeah. So that means the 10 goes with C. 10 goes with C. So then we have 11, 12, 13. So let's see. So give 11 a try. That's not too bad. So it looks like we're here at 0, 3. Can you find a line over here at 3, 0? Let's see. Not really. I guess this one. Sorry, but this one doesn't match up the best. But yeah, so this is, let's say that's -1, 0, right? Let's say that's -1, 0. So we're looking for, so that's our 3. It's supposed to be there, I guess. And then I guess this one works because then we're looking for 0, -1. Yeah, I mean, that works. That works. Yeah, that works. Nice. So there's A. 11 goes with A. So try 12 now. Try 13. Right? You're just switching the X's and Y's. Switching the X and Y's. That's the inverse. So give those a try. I'm pretty sure 13. Pretty sure 13 is probably B, right? And 12 is D. Okay, then we got 14, 15, 16. Nice. So is this a function? So that's definitely not a function because it doesn't pass the vertical line test. Doesn't pass vertical line test, and not one-to-one or onto. This one is, yes, a function, right? It's a function. It's like y equals, I don't know, x -2 all squared minus 2. So yes, it is a function. Maybe that's a 3. I don't know. So yes, it's a function, but one-to-one. Well, the problem is that at 2 coordinates you have the same, let's say the same y value, for example. So you have a y value there, you have a y value there. And so we'll say maybe that's -1, and we'll say that's maybe 5. And since you have -1 and 4, and then 5 and 4, right? So since they share the same husband, I mean the same y value, what? Yeah, it's illegal. You can't do that. No sharing the same husband, no sharing the same y value. Since they share the same y value, then no, not 1-to-1. And that actually affects the inverse, right? So you can't have an inverse function then if it's not 1-to-1. Okay, let's see here, number 17, give that one a try. So yeah, that's an equation of a line, right? Yeah. So that's an equation, wow. So that's an equation of a line. That's an equation of a line, so yes, linear. And 1-to-1, because you have an x value, you have a specific x value, y value, there's no other y value like that matches, right? So yep, that works, nothing else matches, so yes, 1-to-1. Each x value has its own unique y value. Woo! There we go. I like it. I like it. So yes and yes. So give 16 a try. I'm pretty sure that that's yes, a function, also 1-to-1, just like 17. Okay, so this one is going to be extra credit on the test. You want to know how to do it? This one's going to be extra credit on the test. Extra credit on the test. Possibly, probably. Okay, so all you're doing is doing a composition, right? Composition. So we're plugging G into F. So we're taking G and we're plugging it into F. And they are, yes, verify that they're inverses. So yes, inverses if both equal x, or that the f of g of x equals x. So we're going to plug that in there. So we do the third power plus 5. Then we take our cube root there of x minus 5, and we plug it in for x. We plug it right in there. We plug it right in there. Boom. So that goes away. And we're doing compositions, and in its place is the function. Okay, the third power and the third root undo each other. Woo! So they undo each other, so we're just left with x minus 5 plus 5. And then 5 minus 5, they cancel each other out, so we're just left with x. Woo! So this one works. This one works. So now we just have to check this one now. Just have to check this one. So now we're going to plug f into g. So now we're going the other way. We're taking x to the third power plus 5, and we're plugging it in there. So now we have g of f of x, and that's going to be the third root of x minus 5. Again, we're taking the x to the third power plus 5, and boop, 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 plugging it in there. Okay, so then we drop our parentheses, and we're x to the third power plus 5 minus 5. The 5 minus 5 cancel each other out. We still have the cube root going on. And then this cube root and the third power can be written on the outside. So that means that there's, or you could just say there's 3 of them, x times x times x. And that's triplets. So one of them comes out. It also works. Bam. So our answer is both of them equals x. So yes, it's an inverse. Right? So yes, if both equal x, and yes, they both equal x. Because g of f of x also equals x. Woo! So that means yes, they're inverses. Yes, they're inverses. Now you're going to find the inverse of each one algebraically. Just checking our time there. We're still doing good. Okay, so to find them algebraically, you're going to switch the x's and y's and just solve for y. Super easy. So this becomes y is equal to 4x to the third power plus 1. We're going to go ahead and switch our x's and y's. Switch our x's and y's. So now it's x equal to 4y to the third power plus 1. Then we're going to minus 1 to the other side. So we have x minus 1 is equal to 4y to the third power. Then we have to get solve for y now. Solve for y. We're switching to find the inverse. You switch the x's and y's and solve for y. Okay, so now we solve for y by dividing by 4, dividing by 4. Boom. Okay, so then we just have to do the third root now. Just do the third root. So if you third root one side, boom. You have to third root the other side, boom. So now we have y is equal to the third root of x minus y over 4. We want to switch the positions now and say y equals the third root of. Y equals the third root of x minus 1 over 4. And then last but not least, they want you to change it to say that this is now y inverse or f inverse of x equals the function, the third root of x minus y over 4. Woo! There's your answer. You did it. You found the inverse. Way-o. Found the inverse. You found the inverse. So you try number 20. You try number 22. Give 21 a try. 21's a really good one. Very similar to the test. I'm waiting for you. I'm pausing. Pausing. I'm watching. You got to try it on your own. You can't just copy my video. You're going to get it wrong on the test. So again, we got... you try. Come on. You try now. You try. You try. You try. We have y equals the square root of 2x plus 3. Right? We're going to go ahead and power 2 both sides. Nope, 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 nope. We have to switch the x's and the y's first to find the inverse. So now x equals the square root of 2y plus 3. Then we're going to square both sides. Solve for y. So now we have x squared is equal to 2y plus 3. Then we're going to go ahead and minus 3 to the other side. So we have x squared minus 3 equals 2y. Then we'll divide by 2. Divide by 2. So now we have y is equal to x squared minus 3 all over 2. So then we're going to switch those, and so we'll put the y first. So y then equals x squared minus 3 all over 2. And then we say that that's f negative 1 of x, because that's the inverse, equals, so we'll kind of put that right, wow. So then we say that y becomes the notation, right? The notation for inverse is f negative 1 of x equals x squared minus 3 over 2. Woo! There's our answer. Woo! There's our answer. Way-o. There's our answer. Woo! Okay, we'll finish off now. This last page. Okay, so how do we graph these suckers? Right? So how do we graph these suckers? So you first graph the equation. So y equals the square root of x minus 2. Try it on your own. Use your notes. Try it on your own. Then check your answers. So that's going to be right 2. Yeah. So that's going to be right 2. I'm actually going to put that over here. Okay. So that's going to be right 2, and it's a parabola. So right 2 like that. If it lets me. So right 2, and we're going over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4, back to 1, 2, 3, 4. So there's our parabola there. And so now we want to find the inverse function. So we're going to switch our x's and our y's. We're going to go ahead and square root, boom, square root both sides. So the power of 2 goes away, and then we'll add 2 to the other side. So now we have y is equal to the square root of x plus 2. Square root of x plus 2, way-o. So can you graph the square root of x plus 2? So we shift up 2 like this. And then we go over 1, up 1, and over 1, 2, 3, 4, up 2. And so there's our inverse function. There's our inverse function. And so the domain for our inverse function has to map the domain. You can't have a whatchamacallit, right? So you can't have a the one-to-one. One-to-one. Uh-oh. So the one-to-one is uh-oh. So we basically can't have this from our original. You see that? Because it has to be one-to-one. And so there's our inverse. Come on in, guys. Just making a video. So we can't have one-to-one, so we have to get rid of that. Okay, so that means that the domain has to be restricted. The domain has to be restricted. Restricted. So the domain for our first equation is just going to be from 2 to infinity. So that's going to be 2 to infinity. And then the range for that restricted, it's like a restricted parabola. So then that has to be 0 to infinity. And then all we're going to do is switch it for the inverse. So the inverse is actually going to start at 0. So the domain then is going to be 0 to infinity. And then the range is going to be, because that's going to be 0 to infinity. Finishing the video, come on in. 0 to infinity, and then we're going to go ahead and then go 2 to infinity. And so all we're doing then is switching our domains and switching our range. Nice. Switching our domain and ranges. And there we go, number 23. Woo! So the function, you could do your coordinates there of 2, 0, and then you switch it to 0, 2. And therefore, just kind of doing those x values, y values. This would be over 3 up 2. This would be over 2 up 3. I'm just kind of looking at our graphs right there with our coordinates, and then they both share 4, 4, it looks like. Both share 4, 4. Come on in, just finishing a video. Just making a video. Bear with you guys. Okay, last one. So basically, I can tell that they're trying to get a common denominator. Getting a common denominator. Way-o. So it looks like we're trying to get a 12 is what we're looking at here. Trying to get a 12. So we'll times by 4 to the top and bottom, times by 3 to the top and bottom, get a common denominator. So So that'll be x to the 4/12 and y to the 15/12. Well, the crazy part about the y is that if you have a 12th in there, that's going to be the root, and then you have 15. Well, that means you're going to have a whole 12, right? You're going to have a whole 12 come out, and you'll have a 3. You have y to the 3rd power left, basically, right? Yeah. So then you'll still have x to the 4/12. So here's x to the 4/12, and then you also have y to the 3rd left, and then you have a y to the 12th on the outside. Y to the 12th came out. Yeah, woo! Thanks for watching. Woo! Thanks for watching. Ace the test. Thanks. Practice test. Thanks for watching. Shout out to everyone here. Woo! Yeah, thanks for being here. Raise your hand if you want me to shout out your name. Yeah, Bowden. Yeah, Lacey. Woo! Thanks for being here.